Hello students, welcome to Abdemi's platform for physics. Today we will consider a problem from modern physics involving de Broglie wavelength. See the statement of the problem. It is related to quantum theory of matter. So let us see what the problem is. The potential energy of a particle of mass m is given by Vx equal to E naught for x in closed interval 0, 1 and Vx equal to 0 for x greater than 1. Lambda 1 and lambda 2 are the de Broglie wavelengths of the particle when x is in the closed interval 0, 1 and when x is greater than 1 respectively. If the total energy of the particle is 2 E naught, find the ratio of lambda 1 and lambda 2. So, the particle of mass m is having a potential energy, the plot of which we can draw like this. This is Vx, this is x. In the closed interval 0, 1, that means when x is in the interval 0 to 1, the potential energy of the particle is E naught. This is E naught. And it is 0 when x is greater than 1. This is 0. Alright, this is Vx. This is the plot of potential energy. It is defined like this. And when the particle is in this, the spatial coordinate of the particle is in the closed interval 0, 1. The wavelength, de Broglie wavelength of the particle is lambda 1. Here the particle's wavelength is lambda 1, and when x is more than 1, then it is lambda 2. It is stored like that. Total energy of the particle T is actually kinetic energy plus potential energy. I can write kinetic energy as K and potential energy as V. Now total energy is always equal to 2 E naught. That means for x in 0, 1, from this equation you can write K means K1, kinetic energy of the particle in region 1. I call this as region 1 and call this as region 2. So region 1 means region 1 is where x is greater than equal to 0 but less than equal to 1, and region 2 is where x is greater than 1. So K1 is the kinetic energy of the particle in region 1 is equal to P1 square by 2m, where P1 is the momentum of the particle in region 1, and P2 is momentum of the particle in region 2. Simple. So P1 square by 2m is the kinetic energy, and similarly kinetic energy of the particle in region 2 is nothing but P2 square by 2m. Now, from the given condition, I can write. So, in the region 1, total energy is 2 E naught, but it is K1 plus in the region 1, potential energy of the particle is E naught is equal to 2 E naught. Or K1 is E naught, or I can write P1 square is 2m E naught. Alright. Now region 2, if I consider the total energy. So total energy is K2, region 2 kinetic energy is K2, but potential energy is 0 over here. But the total energy is same as 2 E naught. Therefore, P2 square by 2m is 2 E naught. Therefore, P2 square is 4m E naught. So this is one relation, this is another relation. So P1 square by P2 square is half. P2 square is P1 square is equal to P2 square by 2. Okay. So P1 by P2 is 1 by root 2. Alright. But we know the de Broglie wavelength associated with a particle having momentum p is lambda equal to h by p. Therefore, in region 1, I can write lambda 1 is h by p1, lambda 2 is h by p2. So, I can write, so if I just remove this, if I clear this space, so lambda 1 by lambda 2 is equal to P2 by P1, which is equal to root 2. So lambda 1 by lambda 2 value is root 2, root over 2. So this is the answer. It's a very simple problem. So basic principle is de Broglie wavelength associated with a particle having momentum p can be expressed as lambda equal to h by p. Total energy of the particle is k plus v. And it is said that in the region 1, potential energy of the particle is E naught. In region 2, potential energy of the particle is 0. And kinetic energy of the particle K1 in region 1 is P square by half mv square is equal to P square by 2m. So from which we found out the values of P1 square and P2 square. And then taking ratio of P1 and P2, P1 and P2 or P2 by P1 is actually root 2 by root 1. Root 2 itself, that means P2 by P1 is root 2, and we found that lambda 1 by lambda 2 is P2 by P1 is root 2. So from which you could find the value of lambda 1 by lambda 2. I think the concept is clear. Very simple problem, just you have to apply your mind. So with this, I conclude this module. If you have any doubt, please revert back to us. We will further try to clarify. Thank you very much for your listening.